Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Planet X Coming in as Comets and Affecting the Earth. Now, in Article 339 entitled Planet X and the Interstellar Medium Can We Leave the Solar System, I suggested that the Planet X system occupied or was, in fact, the interstellar cloud which surrounds our solar system, based on the observation that the interstellar environment right outside our solar system has experienced an increase in temperature, and that this increase in temperature is what is expected when solar system matter comes into contact with Planet X system matter. The Planet X system is made up of energy-depleted stars, planets, and moons, and their debris, as the objects shed outer layers of material, which then becomes pieces of debris. These pieces of debris vary in size from dust particles to asteroid-sized pieces of rock. The objects belonging to the system share their outer layers because as their gravitational energy drops, and their gravitational energy is in the form of photons inside particles making up the objects, their gravitational influence over their own matter would drop, leading to expansion and the loss of outer layers until the core of the objects is exposed. This is the reason why I often refer to these objects as stellar cores, although the smaller ones would be more aptly named planetary or moon cores. And you may look at Article 236 entitled What are Stellar Cores, and Article 319 entitled Planet X System, Planets, Moons, and Debris for more details. And this image illustrates what the solar system looks like. It appears to be a sphere, although before it was believed to have a tail, but now it is believed not to have a tail at all, but to simply be spherically shaped. Now, observational evidence suggests that the interstellar medium increased in temperature between 2005 and 2015, which is also the time when the sun seemed to show increasing levels of weakness, suggesting that perhaps a larger number of stellar cores started coming in at that time, and that therefore the solar system may have entered a denser part of the Planet X system. It is known that the solar system is close to the edge of the cloud and must have entered it recently. However, recently in astronomical terms may be as long as a few thousand years. It is therefore likely that the solar system in the last few years, since 2005, entered a denser part of the Planet X system, resulting in more of these objects making their way to the sun. And this illustrates the difference in size between the interstellar cloud, which is basically the Planet X system, and the solar system. The solar system, as far as diameter goes, has a maximum diameter of about 240 AU. Sometimes people refer to the size of the Planet X system as going out to Pluto's orbit. Pluto is only 40 AU from the sun, but the very edge of the solar system seems to go out further than that to about 122 AU. Now, the interstellar cloud is 30 light years, which is about 2 million AU in extent. So that would make the Planet X system at least 10,000 times larger than the solar system. Now, what would these objects look like as they come in toward the sun? As I have written in Article 169, Planetary Formation, Comets to Planets, any object coming in toward the sun and coming close to the ecliptic, where the sun's nebular ion clouds are, would develop a comet's tail, and therefore these objects would develop comet tails and would thus be referred to as comets. This means that stellar cores and comets are one and the same thing. And here you see a comet. So Planet X objects or stellar cores come in toward the sun as comets. Now, comets are not dirty snowballs. They are rocky, like asteroids, or they are large and spherical, and thus a stellar, planetary, or moon core. And there is no size limit. And you may look at Article 366, where I detailed some of this. Now, comets are known to come from every single possible direction. They come in at extremely eccentric orbits and often are never seen going around the sun. In other words, they stay with the sun. It is believed that the objects burnt up in the sun's atmosphere. But the presence of large numbers of very small objects, they are about the same size you would expect a small moon or a small planet. And these objects being in the sun's corona, being observed in the sun's corona, belies the fact that they burn up. They seem to survive and remain in the sun's corona, and as they are energy depleted, they absorb energy from the sun and contribute to its continued weakening. But some of the objects that have been observed in the sun's corona are actually larger than the sun, in which case they would come in and be observed as comets, but would most certainly survive the encounter. And this illustrates the type of orbits that comets have as they come in towards the sun, and they make their turn around the sun very, very close to the sun. And this is why the stellar cores go right into the sun's corona. So comets and therefore stellar cores come in at extremely eccentric orbits. They will either then remain in the sun's corona or go out again at extreme speed and continue to orbit the sun in an elliptical orbit, which would bring them back into the sun's corona periodically. They may even come in hyperbolic orbits, but once they go around the sun, they start to orbit it in elliptical orbits. Now, the large stellar cores or huge comets would go around the sun at an extreme speed. They may then make a gravitational connection with the sun, grabbing a large amount of coronal and chromospheric plasma, and may even remain stationary with respect to the sun, whilst the tug of war ensues with the sun and between gravitational and electrostatic forces. Energy would flow from the sun's core to the region of contact. The electric and magnetic field strengths would thus greatly increase at the contact region, and a solar flare may occur as a result. But whether a solar flare occurs or not, the stellar core gains gravitational energy, so its gravitational attraction increases and its positive charge also increases, which causes the repelling force between the objects to gain strength, resulting in the stellar core eventually breaking contact with the sun and being slingshot away from it at high speed. And this is an illustration of the type of gravitational vortex which may form between one of these objects and the sun. When this gravitational vortex forms, the object may remain stationary with the sun for a while. Whilst there's this tug of war between the forces, eventually it is repelled and it's ejected or slingshot. So if an object comes in and has enough of a gravitational attraction or a gravitational influence, so it is able to form this gravitational vortex because it is so close to the sun, then it will be able to draw large amounts of material from the sun's corona in a small amount of time. And not just the corona, they draw material from the chromosphere. And you may look at article 365 entitled Planet X, the cause behind CMEs for more details. Now, once in the sun's corona, so they come in, and once in the sun's corona, which is mainly made out of electrons, envelops both the sun and the object. At that time, the object starts to feel the repelling force from the sun's core, which is positively charged. The object is positively charged as well. And then the object draws material from the chromosphere and absorbs that material and absorbs the energy that is in the material, and this causes its gravitational energy to increase, but it also increases the ions or the protons that it has. They come from the chromosphere, and that causes two forces to repel it: the electrostatic force and the gravitational repelling force between protons and electrons, and that causes it to eventually be repelled and it's ejected. But when it's ejected, it goes out with both coronal and chromospheric plasma. In other words, the sun's negative layer goes out with it, and some of the sun's chromosphere goes out with it, which means that the sun is left with less chromosphere and less corona. And here we see how large these objects can be, and this image was sent to me by Urbain LeVerrier. It's a LASCO C2 image from 2014. And you can see the size of the object that has approached the sun at this time. This object turned out to be 7 times larger than the sun. This is how large a comet can be. And we can see the object pulling large amounts of solar plasma away from the sun. You can see some of that plasma is actually in front of the object because it covers part of its edge. So that indicates that it's very, very close to the sun. And if I draw this circle, which shows where the edge of the object actually is, you can see how close it approached the sun. It approached the sun well within the sun's inner corona. So this is coronal plasma coming from the sun moving towards the object, and obviously the object would absorb a lot of this plasma. Now, the largest stellar cores or comets may also pass close to the sun without the gravitational attraction being strong enough to result in the object making a strong enough connection to hold its position with respect to the sun for any length of time, in which case it will absorb photons and whatever coronal plasma its gravitational force will allow, and will continue on its course out from the sun. Its orbit is likely to be elliptical, and the object will therefore come back to the sun periodically. Each time it passes, it will gain gravitational energy and gravitational influence, so it is likely to be able to grab more material from the sun each time. A stellar core that has enough gravitational energy to be able to become stationary in the sun's corona for a length of time will eventually break away, taking with it a cloud of coronal plasma, and becomes what we call a coronal mass ejection. And you may look at article 365 for more details on that. If it comes in the direction of Earth, the object will interact with the Earth. It will greatly ionize the ionosphere and will create auroral displays around the north and south poles. And this is illustrated here. This is the auroral display around the Earth's south pole. Now, the object is not usually ejected alone. There are so many objects in the sun's corona, and more of these objects, the smaller ones, will most likely accompany the object. So the object may bring with it several smaller moon-sized cores which enter the Earth's atmosphere and create gravitational vortices, i.e. tornadoes, waterspouts, and hurricanes. And you may look at Article 357 for more details on that. It may also bring a few larger planetary-sized objects with it, and these may stay at higher altitudes and create gravity waves on the ocean, experienced as tidal surges, which the powers that be tried to cover up with manufactured hurricanes. As they move over land, these objects will cause the land to break up and fissure. They will cause earthquakes and volcanic eruptions. So in conclusion, stellar cores coming in from the Planet X system of dead stars, a system which is much larger than the solar system and surrounds it on every side, come in as comets. In other words, stellar cores and comets are one and the same thing. These objects draw solar plasma from the sun and approach the sun surrounded in coronal plasma. They ionize the ionosphere and create auroral displays. They are also usually accompanied by many smaller Planet X objects which create gravitational vortices in the form of tornadoes or waterspouts and hurricanes inside the Earth's atmosphere. Larger objects will create gravitational waves on the ocean and cause fissures on land, as well as earthquakes and volcanic eruptions. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.